Let's say, children, now what is the next sum on distance formula trying to say? It says find the point on x-axis which is equidistant from A minus 3, 4 and B 1 minus 4. There is a point on x-axis is what the question says, which is equidistant from point A minus 3, 4 and B 1 minus 4. I'm supposed to find out the coordinate of that particular point which is lying on x-axis. Now children, for that, normally teachers make a sum whereby which they just show you a point which is equidistant from the 2 points. What I would prefer is that if possible then draw a coordinate axis. If possible then draw a very rough coordinate axis. When I say very rough means you need not go for any kind of measurement, mind you, no measurements as such. Find the point on x-axis. So that point could be anywhere on x-axis. When I say x-axis, that means it could be on the negative x-axis here, or it could be on the positive x-axis, that is on the positive side. I repeat, find the point on x-axis. So the point lies on x-axis. Not being told to me that where exactly the point lies. It could be anywhere. It could be on the right hand side of the origin where the coordinates are positive. It could be on the left hand side of the origin where the coordinates are negative. So choice is yours. Choice is yours. You can take point anywhere on x-axis, either on the right hand side or on the left hand side. Mind you, your answer is irrespective to your diagram. It's not necessary that if you take a point here, that means your answer has to be negative. Or for that matter, if you take point here, your answer has to be positive. No, this is only for our reference, mind you. This is only for our reference, right? So may not be, our point will be correct. But yes, on x-axis, why I want you people to do all these things? Because on x-axis, y coordinate is 0. That is what you should remember. On x-axis, y coordinate is 0. That is what I want you people to remember. So find the point on x-axis. I am taking that point, say on the negative side. Say here point A is that particular point. Acha, they have already taken this particular point A, so I'll take this point as point P. I'll take this as point P, which is equidistant from minus 3, 4. Say minus 3, 4 is here. Say minus 3, 4 is here. So this is my point A with minus 3, 4. And B 1 minus 4. B 1 minus 4. Say somewhere here. A minus 3, 4 lies in the second quadrant. 1 minus 4 lies in the fourth quadrant. Right? Again, children, I like to tell you, it is not that material to draw down the points exactly in the quadrant. It's immaterial. Only to make you understand conceptually, okay, this is what the sum could be. So this is my point B, 1 comma minus 4. Now what do they say? Point on x-axis, so which we have taken as P. We are aware that the x coordinate is going to be, y coordinate is going to be 0. So what I'm going to write down this as something x comma 0. Why? On x-axis, y coordinate is 0. Are you getting me, children? Now they say it is equidistant. So PA is equals to PB. PA is equals to PB is what the question says. What am I supposed to find out? I'm supposed to find out the coordinate of point P, out of which with a logic knowledge, with the conceptual knowledge, not logic knowledge, with the conceptual knowledge we are aware that on x-axis y coordinate is 0. So we just need to find out what is the x coordinate. That's what the question is all about. So how we write down? We write down our solution as let point A, which is minus 3, 4, identical equal to x1, y1. Next, point B, which is nothing but 1 minus 4, which is x2, y2. Let this be x3, y3. Let this be x3, y3. Right? So, let point P be the point on x-axis. Let point P be the point on x-axis. Since point P is on x-axis, its y coordinate is 0. Therefore, the coordinate of point P is going to be x comma 0, which we can take it as x3, y3. Right, children? Right? This was the reason I asked you to draw this kind of figure. Mind you, figure has no marks, right? It's only for your understanding purpose. Now, the question says, this point is equidistant from A and B. So when they say it is equidistant, that means, can I say, since point P is equidistant from points A and B, therefore, can I say PA is equals to PB? Or for that matter, can I use the word distance PA is equals to distance PB? Right, children? Can I say distance PA is equals to distance PB? So now when we are aware that it's a distance PA equals to distance PB, then can we make use of distance formula? Can we make use of distance formula by using distance formula? By using distance formula, what is it? Distance PA, what should be the formula? Under root of x3 minus x2 the whole square plus y3 minus y2 the whole square. y3 minus y2 the whole square. This is for PA. Is equals to PB is equals to PB. So what is that PB going to be? If you want, you can write down here. If you want, you can write down here also. Sorry, this is for PA. So let this be x1, y1, children. And this is going to be x2, y2. I'm sorry. So when we say PA, it should be x3 minus x1 and y3 minus y1. Sorry for that. PB, what is that going to be? Under root of, again, x3 minus x2 the whole square plus y3 minus y2 the whole square. x3 minus x2 the whole square, y3 minus y2 the whole square. Children, we want to get rid of this particular square root sign. So what I shall say, taking squares on both the sides. Taking squares on both the sides. The moment we take squares on both the sides, the square root sign gets, right? So along with the substitution one, start your answer. What is x3? What is x3? x3 is x minus. What is x1? Minus 3. x3, which is x minus of minus 3. Can I say x plus 3 the whole square? 0 minus 4. So 0 minus 4 the whole square is equals to. What is x3? Once again, x minus x2. That is minus 1 the whole square. Plus, what is y3? 0 minus of minus plus 4 the whole square. Right? A plus b the whole square. What is it? A square plus 2 into a into b. So 2 into a into b plus b square. Am I right, children? 0 minus 4 is minus 4. Square of minus 4 is 16. Square of negative number is positive. A minus b the whole square. A square minus 2 into a into b plus b square plus square of 4 is 16. X square plus 6x plus 9 plus 16. X square minus 2x plus 1 plus 16. Can't I cancel this 16 and this 16? Can't I cancel this x square and this x square? Bring all the x on one side and constants on the other side. 6x, bring this here, plus 2x is equals to 1. Bring this there, plus 9. 6x plus 2x, 8x is equals to 9 plus 1. Sorry, I'm so sorry. Plus 9 when goes over there, I'm sorry, plus 9 when goes over there becomes minus 9. Plus 9 when goes over there becomes minus 9. 1 minus 9, answer is minus 8. 1 minus 9 is minus 8. X is equals to minus 8 by 8. X is equals to minus 1. Minus 8 by 8, x is equals to minus 1. Still we are not done with the sum. What we are supposed to write down? We need to write the point on x-axis. Our presumption was correct. We took point on the negative side. The x-coordinate turns out to be -1. So since it lies on x-axis, y-coordinate is 0. Therefore, the coordinate of point P, the coordinate of point P is -1, 0. The coordinate of point P is -1, 0. Now, what could be the variety in the sum now, children? What could be the variety in the sum? The same sum can be asked. The same sum can be questioned in this way. What did I say? Find the point on x-axis. There might be one more question stating that find the point on y-axis. On y-axis, x-coordinate will be 0. On x-axis, y-coordinate was 0. So, maybe a next question could be, I'm just drawing a diagram for that. So let me say this is something extra. A point on y-axis is equidistant from, say, 2 points. Say this and this. Say. Then what is the coordinate of this one? On y-axis, x is 0. So 0, something. So with this particular sum, we have learned one more. So the point could be on x-axis also. The point could be on y-axis also. What you people have to remember, on x-axis, y-coordinate is 0. On y-axis, x-coordinate is 0. Children, if you take this basic knowledge, sums are very simple. Mind you, this is very simple.